The next type, which is part of a non-rectangular data in pipeline for us, is a graph data. Graph data. So what is a graph data? The data that is organized into nodes, points and edges, or we can call it as the lines, where the edges represent the relationships or connections between the nodes. So examples include social networks, road networks, and molecular structures. So let me show you some of the examples. So social networks such as Facebook or Twitter. Let me show one example so that it would be much clear. Let me get it here. Yep, this is what the Facebook network or Twitter network. So Diva, Devon, Dude, Ken, Barbie. So now if you see Barbie, this is called a pointer. This is a pointer. This is a point, or you can call it as a node. So these are all nodes, and then each node is joined through a line, or can call as edge, is what makes the relationship. Now if we take Barbie is connected with our point of interest. Our points of interest are Barbie, Ken, Dude, Devon, and Diva. These are all marked in pink, and remaining are in blue. We are no, these are not for our interest. So now, so this Barbie is connected with this. So 1 2 3 4 5 6 directly. Okay, directly. These are the primary contacts, and it's also connected with the Ken. That's also primary contact. Whereas the Barbie is connected to the Diva through this blue connection. So this is a secondary contact if it has connected. Whereas, and if you see Jude is also primary contact to Barbie. Whereas Devon and Dude, there is no primary contact at all. Whereas Diva and Dude has a primary contact. So, and if you see this blue dot and then Dude, there is no contact at all, neither primary nor secondary nor tertiary. If you see your LinkedIn, you will find out the primary, secondary, and tertiary. So why? Because that's how this is how the data will be graphed. This is how the data will be collected. So this kind of data is known as either LinkedIn or Twitter or Facebook. So all these connection data will be collected in graph data format. So this is the best example for the graph data. So there you can see the points, or you can call it as a node, and then lines, or you can call it as edges on your screen. That's one example. Then after that, you have road networks such as Google Maps or GPS systems. So let me get into the Google Maps directly. And if you see, this is the Google Map location of Voyo Townhouse, Ramurthy Nagar. So that's where we are. So now, if you see the roads, how the roads are connected and each location. So this is also a road network, and whichever your point of interest, that will be marked as a node, and remaining all are connected as a line. See, everything is connected as a lines or edges, and that actually tells about the relationship between the one node to another node. And this is the best example, so that road networks such as Google Maps or GPS system. Okay, then we have molecular structures in chemistry or biology. So let me show you that. Yep, this is what a caffeine molecule. I hope everybody drinks caffeine, or the takes intake is very high these days. So what is caffeine? The caffeine chemical name is 1 comma 3 comma 7, the methyl methylaxanthine. Okay, so the chemical formula is C8H10N4O2, and you can see that these are all called hydrogen these the mechanical bonds, the bond between a carbon and a nitrogen or a hydrogen. These are all called mechanical bonds. I hope you know that there are three types of bonds mainly. One is a covalent bond, and then ionic bond, and then metallic bond. So at this moment, I'm taking a software. I'm taking data science course and not chemistry course, or else I would have explained what is covalent bond and what is ionic bond and what is metallic bond, because that's not a point of interest for us. So here what we are interested about is that the molecule, the atom which is connected is the node for us, and then the line which connects tells us the relation. If it is a single line, it's a single bond. If it is multiple lines, it's a multiple bond. And you see, C is carbon atom, and H is hydrogen atom, N is nitrogen atom, and O is oxygen atom. CH3 is methyl radical. Okay, so this is what the atomic structure of the caffeine molecule. So the caffeine molecule, uh, uh, the atomic structure can be represented using graph data, using the nodes and the line, and each node represents a particular atom. Okay, and we have one more example. Let me get back to the so the other one is dependency graphs in software engineering. So let me get into the dependency graphs. Yep, this is what is our dependency graph in software engineering. I hope many of the one who is watching either working in software industry or had some experience in software industry, or wishing to enter into the software industry. Okay. Anyhow, so always the project begins with the requirements gathering. Most probably a business analyst comes into the picture and takes this uh, a huge work on his shoulder. Then after that, it goes into the system designs, and the system design will be in two ways: detailed design 1 and detailed design 3. So you will be making three designs: detailed design 1, 2, 3, and from there it's parallelly goes build 1, test 1, build 2, test 2, build 3, test 3. We are talking about the agile methodology, and then finally you integrate all the components together. So detail 1, 2, 3, all designs, and then all builds together, and then finally we'll do the integration test. It's not the exact replica of what happens in software industry, but I just want to give you a simple example to represent a graph data. So these are all called as the nodes, and then the relationship, the lines, the arrows which join from one to other tells about the relationship between the each node. So these are the primary and the most important examples for the graph data. And if you get a certain type of project on maybe Twitter or LinkedIn, obviously you will end up in working with graph data and non-rectangular data. So how will you do that? How will you handle it? So that's the reason I'm telling you, before you start working on a project, there is not just a rectangular data, there are huge amount of other types of data too.